Good morning, middle one. How are you today? Let's start to solve these problems about the potential energy and kinetic energy. Lesson 1, Unit 2, potential and kinetic energy. Okay, number 1, if the work done to move a distance of 2 meters equal 40 joule, calculate the force. Calculate the force. You know that the work done equal force times displacement. Force times displacement. So the force equal work done divided displacement. So the force equal, he need the force. So the force equal work done is 40 divided 2. So the force equal 20 Newton, because the unit of the force is Newton. Number 2, find the weight. Find the weight. Find the weight of an object whose mass is 5 kilogram. If you know that the acceleration due to the gravity is 9.8, he need the weight. So the weight equal what? Equal mass times acceleration of the gravity. So the weight equal mass times acceleration of the gravity. So the weight equal mass is 5 times gravity 9.8, so it equal to 49. Weight is measured in Newton. Number 3, if a pole throwing to reach 20, if a pole throwing vertically to reach 20 meter height, and its weight is 5 Newton. Calculate its potential energy at A, at the highest point, and also at the ground. So number A. Potential energy at highest point. At highest point equal what? The potential energy equal weight times height. Equal weight times height. Okay? So the weight is 5 and height is 20, the highest point. So the highest point is, or the height is 20. So it's equal to weight 5 times height is 20. So it's equal to 100 joule. 100 joule. Okay, but at reaches to the ground, potential energy at the ground is equal 0, because the potential energy when they reaches this pole to the ground, so the potential energy also, all the potential energy transformed or it changed into kinetic energy, so the potential energy reaches to 0 or reaches to the minimum, which is 0. So the potential P, the answer B, potential energy on the ground equal 0. Okay, number 4, problem number 4, calculate the mass of the speed. Calculate the mass of a pole, of a speed 30 meters per second. Okay, if you know that its kinetic energy equal the kinetic energy of a basketball of a mass 7.5 kilogram and moving by a speed of 6 meters per second. So the kinetic energy of this pole equal to the kinetic energy of the pole of the basketball. So first we need to calculate the kinetic energy of a basketball. The kinetic energy of a basketball that equal to half, kinetic energy equal what? Equal half mv square, equal half mv square. So the kinetic energy of the basketball equal half times m 7.5 times v square speed, moving a speed of 6 meters per second. So 6 to the power 2, so it's equal to 36. So the kinetic energy of the basketball equal half mv square, so it will be equal to 135 joule. Okay, here he needs the mass of the pole of a speed 30 meters per second. If you know that the kinetic energy of this pole equal to the kinetic energy equal to 135, so the mass of the pole, mass of a pole of the pole equal mass of the pole equal to kinetic energy divided speed to the power 2 divided the speed square, speed to the power 2. So the mass of the pole equal 2 times 135 divided speed to the power 2 30 times 30. So divided 900. So these calculations make the calculation. So the mass of the pole equal 0.3 kilogram. The last problem, a stone of 5 kilogram, mass falls, stone of 5 kilogram mass falls from 8 meters height. What is the potential energy and what is the kinetic energy in each of the following? Number 1, at the start of the falling. Number 2 or B, at height 2 meters, and number C, on reaching the ground. Okay. So he gives you the mass and the height. Okay, give you the mass and the height. Knowing that consider that the gravity acceleration equal to 10 meters per second square. So first, we need to calculate the weight. Okay, first, we need to calculate the weight that weight equal mass times acceleration of the gravity. So equal mass is 5 times 10, acceleration of the gravity equal 10. So the weight equal 500. I'm sorry, 50 Newton. Okay. Second, he needs the potential energy at the starting of falling. So the potential energy equal what? Equal weight times height. Weight times height. So the potential energy equal weight times height. So equal weight 50 Newton times height 8. So equal the potential energy at the starting point equal 400 joule. Okay, this is number A. And he needs also the kinetic energy at the starting point. So the kinetic energy at the starting point equal 0 because the kinetic energy is equal 0 because the kinetic energy at the starting point is minimum is equal to 0 because the speed equals 0. So the kinetic energy equal to 0. B. He needs the potential energy at height 2 meters. So the potential energy at height 2 meters equal weight times height. Weight equal 50 times height 2 So the potential energy equal 100 joule. Okay, but the kinetic energy equal what? The kinetic energy equal what? You know that at the starting of falling, the potential energy, the mechanical energy equal the potential energy only, because the kinetic energy equal 0. So the mechanical energy equal the potential energy at highest potential energy at highest or at the maximum high, which is the 400 joule. 400 joule. So the kinetic energy equal mechanical energy minus potential energy. So the kinetic energy equal mechanical energy minus potential energy, mechanical energy minus potential energy, that equal to mechanical energy 400 minus 100. So the kinetic energy equal 300 joule. Okay, the last one, C. On reaching the ground. On reaching the ground, so the potential energy equals 0. So the potential energy equal 0. The kinetic energy equal mechanical. The kinetic energy reaches to the maximum, which is equal to mechanical energy that equal to 400 joule. Okay, this is the last problem in our session today. Thank you, middle one. Goodbye.